Okay, let's take a look at finding equivalent fractions. And we are going to look in your packet on page 11. So open up to page 11 in your fractions packet. Yesterday we talked about comparing fractions. Today we're going to look at finding equivalent fractions or fractions that are equal. So we can use models to find equivalent fractions. It says a fraction can have many different names. Fractions that name the same amount are called equivalent fractions. For example, let's find some fractions that are equivalent to 1/3. Step 1, draw a model to represent 1/3. So here's a model that represents 1/3. Okay, a pie, and we filled in one piece out of the 3. Then, step 2 says we could divide each of those in half. So notice they kept the 1/3, but they split each section into 2. Okay? 1/3 then is equivalent to 2/6 because here we had 1/3 in the first model. In the second model, we have the same section, but it shows 2/6. Both fractions name the same amount. Step 3, we could take that part from part 2 and divide it again in half. Okay? And now instead of 2 sections, we have 4 sections shaded in. So we have 4, but now instead of just 6 pieces, we've split it into 12. So we have 4/12. So in this case, 1/3 is equal to 2/6. But it's also equal to 4/12, or equivalent. We call equal fractions equivalent fractions. Okay? So let's practice with using models to find equivalent fractions. It says use the models below to write an equivalent fraction. You'll need to divide the parts of the second model to make an equivalent fraction. So they show us 2/4, right? 2/4 shaded in. So to find an equivalent fraction, we still want that 2/4 shaded, but then we're going to split it in half. And now instead of 4 sections, we're going to make 8 sections, and with those 8 sections, 4 of them are shaded. So 2/4 is equal to 4/8. Okay, we can do the same thing with 3/8. Let's shade in the 3/8, but now we're going to split each section in half. So if we split it in half, we now have twice as many sections, which is 16 sections. And with them shaded, we have 6 of them shaded, so 6/16. Okay, let's look at 2/5. If we split our 2/5 in half, now instead of 5 sections, we have 10 sections. And if we had that shaded to start, 4 of those still are shaded. So 2/5 is equal to 4/10. Okay. 4/6. If we take those 4/6 and we split each section in half again, we've now doubled our sections, right? But this is what we had shaded. So, I should have split that better. So instead of 6 sections, we have 12. And now we have also doubled the amount that we have shaded from 4 to 8. Okay? We can do the same thing with 5/6. Let's split each of those sections in half again. And now instead of 6 sections, we have 12 sections. And if 5 of them were shaded before, since we've doubled the sections, 10 of them are shaded now, making 5/6 equal to 10/12. 3/4 we can do as well. So here are my 3/4, right? If I cut that shape in half, now instead of 4 pieces, I have 8. But I have 6 of them shaded. Okay? That's how we can find equivalent fractions using models. It's not always the easiest to find equivalent fractions using models, though, because we have to make sure that we draw exact equal pieces when we do that. So let's learn another strategy, okay? Here it says the word equivalent means the same. If we look at page 12, so the word equivalent means the same. So 2/4 is the same as 1/2. 2/4 and 1/2 are two names for the same fraction. They are equivalent fractions. So notice here we have 2 pieces shaded out of the 4. Here we have 1/2 shaded out of just 2. We've shaded the same amount of a full circle, meaning that those are equivalent. So we can cross multiply when we, just like we did when we compared fractions, cross multiply to check if two fractions are equivalent. So we would say 2 times 2 is 4, and 4 times 1 is 4. So, because 4 equals 4, 2/4 is equal to 1/2. Okay? So now instead of comparing fractions, we're checking for those equivalent fractions with that cross multiplying. So here, cross multiply to check for equivalent fractions. Put an equal sign between the two fractions if they are equivalent. So here we would have 2 times 8, that's 16. 3 times 4 is 12. They are not equivalent, okay? In fact, 16 would be greater than 12, right? So 2/3 is greater than 4/8. 1/4 compared to 4/16. Well, let's cross multiply. We have 1 times 16 and 4 times 4, okay? 4 times 4 is 16, and 1 times 16 is equal to 16. So those are equal, okay? 6/9 compared to 2/6. Well, 6 times 6 is 36, and 9 times 2 is 18. So those are not equal. 6/9 is greater than 2/6. Okay? Let's look at 4/5 and 8/10. If we cross multiply, 4 times 10 is 40, and 5 times 8 is also 40. Okay? So those are equal. So notice we can compare fractions, finding equivalent fractions by using that cross multiplying method, right? Let's try just 2 more. 3/6 and 2/8. Go down to number 8, 3/6 and 2/8. Well, 3 times 8 is 24. 6 times 2 is 12. So those are not equal. 24 is greater, so 3/6 is greater, okay? Let's try number 12, 2/4 and 5/10. 2 times 10 is 20, and 4 times 5 is also 20, so these are equal, okay? Let's take a look at page 13. Sorry, the number kind of cut off, but we're on page 13 here at the bottom, okay? Page 13, we are also going to find equivalent fractions, and it says, here's a quick way to find equivalent fractions. Example, 1/3. Count the numbers you see. Cross multiply to check it out. So here, if we take 1/3 and we count by ones, go 1, 2, 3, 4, 5, and then on the bottom count by threes, 3, 6, 9, 12, 15. Let's see, is 1/3 equal to 2/6? Is 2/6 equal to 3/9? And so forth. And we could find that by cross multiplying, right? 3 times 2 is 6. 1 times 6 is 6. 6 times 3 is 18, and 2 times 9 is also 18. So those are equal, right? Those are equal. If we do that again, 9 times 4 is 36, and 3 times 12 is 36, making these equal, okay? 12 times 5 is 60, and 15 times 4 is 60, so these are equal. Notice we could even say 1 times 2 is 2, 3 times 2 is 6, okay? We could take that and multiply a numerator and denominator by 2 to get 2/6. We could take that 1/3 and multiply the numerator and denominator by 3 to get 3/9, and see how I'm getting that. We can either skip count to get those and line them up, or we can do multiplication and get those same numbers. So for number 1, let's find equivalents for each. 3 equivalents, so 1/6. So if we count up by Ones, here, we're going to have 2, and then 3, and then 4, right? And if we count up by sixes, we're going to have 6, 12, 18, and 24. And that was the same as multiplying by 2 to find 2 twelfths, multiplying numerator and denominator by 3 to find 3 eighteenths, multiplying by 4 to find 4 24ths. Okay. Then let's look at 3/4. Again, let's try that same strategy. Count up by threes for the numerator, so 3, 6, 9, and 12, and count up by fours for the denominator, 4, 8, 12, 16. So that gives us 6 eighths, 9 twelfths, and 12 sixteenths for equivalent fractions to 3/4. Let's try that for 2/5. Count up by twos, 2, 4, 6, 8, right? Make your line for the separating numerator and denominator. Count up by fives for the denominator, 5, 10, 15, 20. Now, if you don't skip count correctly, you're going to make mistakes. So it might be better for you to multiply, right? It might be better for you to say 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. Oops. Sorry, the internet cut out on me. Let's try equivalent fractions for 1/4. Again, count up by ones for the numerator because that's what our numerator is. So 1, 2, 3, 4. Count up by fours for the denominator, 4, 8, 12, 16. And we have found our equivalent fractions of 2/4, 3 twelfths, and 4 sixteenths. Okay. What I'd like you to do today is I want you to, you can write it in your packet, but I want you to do it on a separate piece of paper. Put your name on it. Okay. Let me just zoom out a little bit. Put your name on it and do page 13, number 10, let's see here, number 9, 10, and 11. 9, 10, and 11. Okay, so you'll write number 9, and then you're going to write 2/4 equals, and I want those 3 separate fractions. Okay, then you'll write number 10, and you're going to write 2/10, and I want those 3 equivalent fractions, and I should see those equal signs between them. Okay, then number 11, same thing for 1/8, 3 separate fractions. When you're finished, turn it in.